Hello all. In this session we are going to see about process scheduling. So in our last session we have seen about process state, process control block and followed by threads. So here we'll be seeing process scheduling. So process is nothing but a program in execution. Right? Executable state of our program will be called as the process. So for example, take I'm having one CPU. I'm doing multiple tasks in my using my CPU. For example, I'm listening to music. Simultaneously, I'm browsing something in my browser, and also I'm downloading some files in my browser. Okay, so how many processes I'm doing it simultaneously? 3 processes I'm doing it, right, in my CPU. Correct. But a CPU among process switches. Okay, வந்து எப்படின்னா, for example, I'm listening music, I'm typing something in my browser, I'm downloading file. Okay, I said no, 3 process I said no. ஆனால் அந்த 3 ப்ராசஸும் வந்து switch over ஆகும் among CPU frequently. But as a user, நம்மளுக்கு வந்து மூணுமே simultaneously execute ஆகுது தான் தெரியும். But the CPU, what it will do, it will switch the CPU among the process, okay, frequently, so that the user can interact with each program while it is running. And the concept that we are saying it as the time sharing. So beginningலே வந்து நம்ம பார்த்தோம், டைப்ஸ்ல வந்து பார்த்திருப்போம் time sharing operating system. அதெல்லாம் வந்து we have come across programming, multiprocessor அதெல்லாம் பார்த்திருப்போம். Okay, same concept தான். So see the first point, the objective of multiprogramming is to have, so multiprogramming, okay, so some process running at all time so as to maximize the CPU utilization. So CPU வந்து many space will be there in CPU, so we have to maximize the utilization of our CPU so that we have to run a multiple process simultaneously. Okay, all time not let our CPU to be in a ideal stage. Okay, minimize always it should be in the maximize stage. That's what we are running a multiple program simultaneously. Okay, so see second point, the objective of time sharing is to switch the CPU among process so frequently that user can interact with each program while it is running. That is, I said no, 3 things, listening to music, typing something and downloading something. Okay, so actual scenario la pathomna 3 things வந்து simultaneously நம்மளுக்கு நடக்கிற மாதிரி இருக்கும். But CPU what it will do, time sharing use பண்ணி a frequent switch over it will happen in a CPU. Okay, but அது வந்து நம்மளுக்கு தெரியாது, in depth வந்து CPU will be doing that. Okay, so first concept we have seen about multiprogramming. Second concept வந்து time sharing we have seen. Okay, so in order to meet this objective, okay, so these two objective, the process scheduler selects an available process. Okay, so what are the process available? I mean, set of several processes will be there, okay, but a CPU, a process scheduler, has to select a available process alone from the program execution on the CPU. Clear? So CPU la program execute ஆகிறதுக்கு நிறைய இருக்கும். Okay, அந்த ப்ரோக்ராம்லாம் எக்ஸிக்யூட் ஆகணும் நிறைய இருக்கும். ஸோ அதுலேயே நிறைய ப்ராசஸஸ் இருக்கும். அதில் வந்து அவைலபிள் ப்ராசஸ் alone we have to select it from the several process. Okay, நிறைய processல we have to select the available process alone and we have to execute on a CPU. Clear? So in order to meet these two objectives, the process scheduler what it has to select the available process from the set of several available processes. For what? In order to execute on the CPU. Clear? So next, and uniprocessors is the single processor ன்னு சொல்லுவோம், and multiprocessor ன்னு இருக்கு. கரெக்டா 2 types of process. Unina single, multina in multiple, one or more above. Okay, so for a single processor or the uniprocessor system, there will never be more than one process running. ஓகேவா? ஸோ யூனி ப்ராசஸ்ன்னு சொல்லியாச்சு. அப்போ ஒரு ப்ராசஸ் தான் நம்மளுக்கு வந்து ரன் ஆகும் சிபியூவில். கரெக்டா? பட் இஃப் தெர் ஆர் மோர் ப்ராசஸர் எக்ஸிஸ்ட்னா the rest will be in wait until the CPU is free and can be rescheduled. Okay, so ஒரு processor இருந்துச்சா ஒரு processor automatically it can run it. Okay, don't need to wait for anything. But if there are more process now, the rest of the process will be waited to until the CPU வந்து free ஆகிற வரைக்கும் வெயிட் பண்ணும் and can be rescheduled according to the time given by the CPU. Okay, that is the uniprocess and the multiprocess. Clear? So next is the scheduling queues. Okay, so three types of queues we have here. One is the job queue and a ready queue, and another one is the device queue. Okay ma'am, so all the process will be placed in our queue is called as the job queue. Okay ma'am, so எல்லா ப்ராசஸும் என்னென்ன ப்ராசஸ் வந்து எக்ஸிக்யூட் பண்ணுறதுக்கு இருக்கோ அது எல்லாமே ஆல் டுகெதர் they place in a on place. Okay, that is called as the job queue. Okay, see the first point, as processor enters the system. Okay, some process I'm assigning it that is entering into our CPU, they are put it into a job queue. So enna process நம்ம assign பண்றோமோ எல்லாம் job queue ல இருக்கும். So this queue consists of all the processes in the system. Clear? So next is the ready queue, which means a multiple process I am placing in a job queue, right? So I am taking some process to execute it. அப்போ அது வந்து executable stageல இருக்கு, run ஆற stageல இருக்கு. It is been ready. Okay, so ஒன்று வந்து அது ரெடி ஸ்டேட்டில் இருக்கணும், இல்லைனா வந்து it has to be in a waiting stage for some IO. Okay, IO devices, input output like that. Okay, so அது எல்லாமே place பண்ணி வைக்கிற place வந்து ready queue. Correct. The processes that are residing in main memory and are ready and waiting to execute are called as the ready queue. Okay va, this queue is generally stored in a linked list. Data structure la paathirupom, queue, stack, list, linked list ellame. Okay va, linked list la irukum. Linked list theriyumle two boxes irukum, or line varum, again boxes line join பண்ணிட்டே இருக்கும், head and tail join ஆகும். So that is called as the linked list. A ready queue header contains the pointer to the first and the final process control block in the list. இத பாருங்க. Okay va, this is the ready queue, right? So ready queue la இது linked list la போதா, so இங்க இங்க join ஆகுது, இங்க இங்க join. இதெல்லாம் process control block. As I told already previous பார்த்தோம் இல்லையா, process control blocks la multiple thing இருக்கும், அதுல register is ஒன்னு நம்ம வந்து important பார்த்திருப்போம். Correct? So இங்க head tail it has to be attached like that என்ன linked list format ல இருக்கும். Okay, so a ready queue header contains the pointer to the first and the final process control block in the list. Adhan the pointer. Clear? So next, each process control block is extended to a pointer field that points to the next process control block in the ready queue. So next it has to be pointed. Okay, point ஆயிட்டே தான் இருக்கும். The operating system also has other queue. So our OS also has other separate other queue it has been having. Okay, when a process is allocated to a CPU, I am assigning some process or allocating a process to a CPU. Correct? It executed for a while and eventually quits or interpreted or wait for some event to occur, such as the completion of the IO request. So அப்போ அந்த மாதிரி டைம்ல வந்து OS system வந்து separate queue form பண்ணி they will be keeping some such kind of process there. இந்த மாதிரி sometimes வந்து some interrupt occur ஆயிருக்கலாம், suddenly quit ஆயிருக்கலாம், some wait for a occurrence ஏதோ ஒரு particular eventக்கு இல்லனா வந்து input output requestக்கு வந்து wait பண்ணிட்டு இருக்கோம். ஓகேவா, சோ அப்போ operating system has a separate queue to place all these process. அது அந்த மாதிரி processல வந்து அங்க place பண்ணுவாங்க. சோ அதோட ரீசன் தான் இங்க கொடுத்திருக்கோம். இந்த மாதிரி ரீசன்காக they will be placing those process in a separate queue in a operating system. Okay, in case of an IO request, okay, I am giving some IO request. Such a request may be dedicated tape drive or to a shared device such as the disk. So any request I am giving a tape drive or shared device or disk. Since the system has many processes, okay, many processes irukku disk, I mean system la. Okay, so disk may be busy with the IO request of the some other processor. So at that time the particular disk or the drive or shared devices will be busy. எதனால IO request other process கேட்கறதுனால பிஸியா இருக்கும். ஸோ அதனால ரிமைனிங் திங் will be in the waiting stageல இருக்கும். ஓகேவா, once it has been freedனா தான் வந்து it will move to the another request and process it. ஓகேவா, ஸோ இது புரியுதா? ஸோ டயக்ராம் இது linked list format தான். ஓகேவா, ஸோ அதை ரெடி queue and various IO devices queues ன்னு சொல்லியிருக்கோம். ஓகே, ஸோ it has been merged. ஏதாவது ஒன்று கூட போட்டுக்கோங்க. first thing alone is okay. Okay, so next, device queue. The process therefore may have to wait for the disk. The list of process waiting for the IO devices is called as the device queue. So IO input devices ko output devices ko wait பண்ணிட்டு இருக்கும் இல்லையா some processes. So அதெல்லாம் செப்பரேட்டா ஒரு queueல வந்து வச்சிருப்பாங்க. ஃபர்ஸ்ட் வந்து job queue, எல்லா ப்ராசஸும் பிளேஸ் பண்ணியிருக்கிறது job queue. So second one is the ready queue, a process which is going to be executed or waiting stage la irukku, ready state la irukradala வந்து will be placed in a ready queue. And third one is the IO device. Okay, IO device காக வெயிட் பண்ணிட்டு இருக்க process will be placed in the device queue. So each device has its own device queue. Okay, ஒரு device க்கு each device queue will be there. Clear? So see next point. So process scheduling oda queuing diagram da idu. Okay va, so before diagram is the ready queue da paathom, idu vandu process scheduling oda queuing diagram. Okay, representation. So common representation of process scheduling is the queuing diagram. Okay va, so it has been given in a figure 4.5. Yeah, each rectangular box represents the queue. The rectangle box itla vandu queue. Two types of queues are present, ready and the set of device queue. Okay, so job queue ன்றது வந்து set of processes. Okay, அதுல இருந்து நம்ம process select பண்ணதுக்கு அப்புறம் தான் actual process will taken place, correct? So that's why they are saying as the two types of queue present. இங்க நம்ம represent பண்றது ready queue and the device queue. Okay, ready queue வந்து ரெடியா இருக்க எக்ஸிக்யூட் ஆகிறதுக்கு and will be in waiting stage. Next வந்து device queue வந்து IO deviceக்காக வெயிட் பண்ணிட்டு இருக்கோம், கரெக்ட்டா? So the circle represents the resources that serves the queue. Circle la irukalla adala resources, CPU resources, IO device resources, child execute, interrupter, sorry, IO on the CPU, adu mattum da idu vandu oval shape, correct? So these two are the resources and the arrow indicates the flow of processes. Okay va, so and the flow in the direction la vandu நம்ம process oda flow irukudன்றத அந்த காமிப்பாங்க. Okay, a new process is initially put in the ready queue. It waits in the ready queue until it is selected for the execution. Okay, a new process, so job queue la we have taken some new process, adu ready queue ku vandirchu. Okay, so anga ready queue la enna pannom already sonna, once it ready na ready la irukum, illana vandu wait na wait adu ready la irukum sonnom illaya. So a new process initially put in the ready queue, it's wait in the ready queue until it is selected for the execution. So CPU ada select பண்ற வரைக்கும் it will be waited there. Okay, once the process is assigned to the CPU and is executing, one of the several event could occur. So okay, execution க்கு வந்து CPU select பண்ணிட்டாங்க, so it has moved to the CPU. Okay va, so அங்க மூவ் ஆனதுக்கு அப்புறம் இந்த ப்ராசஸ்ல ஏதாவது ஒரு ஈவென்ட் வந்து அக்கர் ஆகும். Okay, அதான் இங்க கொடுத்திருக்கோம். A process could issue IO request and then placed in the IO queue. ஒன்று அந்த ப்ராசஸ் வந்து ஐஓ ரெக்வஸ்ட் அட்டம் பண்ணி ஐஓக்கு வந்து வெயிட் பண்ணுறதுனால ஐஓ கியூவில் இருக்கலாம். ஓகேவா? செகண்ட், தி ப்ராசஸ் கிரியேட் அ சப் ப்ராசஸ் அண்ட் வெயிட் ஃபார் தி டெர்மினேஷன். ஓகேவா? ஸோ எல்ஸ் சப் ப்ராசஸ்க்கு வந்து வெயிட் பண்ணிட்டு இருக்கோம். ஓகேவா? சாரி, கிரியேட் ஃபார் அ நியூ சப் ப்ராசஸ், ஆல்ரெடி இது மெயின் சப் ப்ராசஸ், அது என்னது சப் ப்ராசஸ்க்காக கிரியேட் பண்ணிவிட்டு அது முடிச்சுட்டு வெயிட் பண்ணுறதுக்காக terminationக்கு வெயிட் பண்ணிட்டு இருக்கோம். ஓகேவா? So next, a process could be removed forcibly from the CPU. ஓகேவா? CPU என்ன பண்ணுவாங்க, அசைன் பண்ண ப்ராசஸை them itself forcibly to remove. இதனால as a result of interrupter to put back in the ready queue. ஓகேவா? ஸோ சம் இன்டரப்ட் டிஸ்டர்பன்ஸ் அக்கர் ஆகியிருக்கிறதுனால ஸோ அவங்க கேன்சல் ரிமூவ் ஃபோர்ஸபிளி பண்ணிவிட்டு அகெயின் என்ன பண்ணுவாங்க, புட் பேக் இன் தி ரெடி கியூவில் வந்து புட் பேக் பண்ணுவாங்க. ஓகேவா? அது ஒர்க்கு பாருங்க. வெயிட் ஃபார் இன்டரப்ட் ஆகினா ஆச்சுன்னா அகெயின் ஃபர்ஸ்ட்லேருந்து வரும். ஓகேவா? ஸோ டைம் ஸ்லைஸ் எக்ஸ்பயர் ஆகிடுச்சுனாலும் அகெயின் ஃப்ரம் பிகினிங்லேருந்து வரணும். ஓகே, டைம் ஸ்லைஸ் ஆல்ரெடி ஹேவ் டோல்டு பிகினிங்கில். ஓகேவா? நெக்ஸ்ட், இன் தி ஃபர்ஸ்ட் டூ கேசஸ் தி ப்ராசஸ் இவென்ச்சுவலி switches from waiting state to the ready state and put back in the ready queue. First two state. Okay, a process continues this cycle until it terminates. In the process, okay, enga varudhaleya again it running, right? So the complete and the process complete ஆகிற வரைக்கும் இந்த process வந்து again and again run ஆகிட்டே தான் இருக்கும். Okay, at which time it removed from the queue and it has been is process control block and resources deallocated. Once it has been, everything is controlled and finished, it has been deallocated. Resources வந்து they will be deallocated. Clear? So next is the scheduler. Okay, so a process இருக்குல்லையா, a process வந்து will be changing their places. Okay, various scheduling queue, already 3 queue பார்த்தோம் இல்லையா, job, ready queue and job queue. Okay, அந்த அவங்களோட process வந்து terminate ஆகிற வரைக்கும் they will be migrates என்னது will be moved from one place to another place, okay, until their process has to be perfectly terminated வரைக்கும் migrate ஆயிட்டே தான் இருப்பாங்க. Okay, so அதுக்கு வந்து we need a certain schedulers. Okay, so that's why they're saying the process migrates between the various scheduling queues, okay, throughout its lifetime. So lifetime in the sense what, until our process terminate பண்ற வரைக்கும் அவங்களுக்கு lifetime, correct? So the operating system must select for scheduling purpose process from the queues in some fashion. Selection process carried out by the appropriate scheduler. So on the selection process வந்து using three types of scheduler இருக்கு, long term, short term and the middle term, medium term scheduler னு three types of scheduler இருக்கு. So இதில் இருக்க appropriate scheduler அவங்க select பண்ணி தான் selection process has to be taken place அப்படி சொல்றாங்க. ஓகேவா? So let's see what is a long term scheduler or the job scheduler. Okay, again this will be asked in your 2 mark questions. Okay, scheduler and types கேட்பாங்க, or what is job scheduler, CPU scheduler and medium term scheduler they will be asking, correct? Okay, so job scheduler select process from the pool nanadu ஒரு நிறைய process வந்து place பண்ணி வைக்கிறது pool, okay, and load them into a memory for execution. Okay, already நான் முன்னாடி பார்த்தது தான். Okay, எல்லா ப்ராசஸும் ஒரு பிளேஸில் இருக்கும், அது வந்து என்ன பண்ணுவாங்க, லோட் them into a memory for execution. அதுதான் நம்மளுக்கு வந்து ரெடி கியூ, எக்ஸிக்யூஷனுக்கு நம்ம மெமரியில் பிளேஸ் பண்ணுறது நம்மளுக்கு ரெடி கியூ. பிஃபோர் எல்லாமே ஒரே பிளேஸில் வச்சுருக்கிறது வந்து ஜாப் கியூன்னு பிஃபோராக பார்த்தோம். ஸோ தட் இஸ் ஜாப் ஷெடியூலர். செலக்ட் ப்ராசஸஸ் ஃப்ரம் திஸ் கியூ pool and load them into memory for execution. Okay, so next is the CPU scheduler or the short-term scheduler. This selects from among the processes that are ready to execute and allocates the CPU to one of them. So again CPU scheduler is otherwise called as the ready queue. Okay, process select பண்ணியாச்சு, அது ரெடியாக இருக்குது இதுக்கு எக்ஸிக்யூட் ஆகிறதுக்கு. Okay, so the primary difference between two scheduler is the frequency of their execution. Okay, frequency na the level, the range of the execution da வந்து இந்த main two scheduler க்கு வந்திருக்க primary distinctions. Okay, okay, see, the short term scheduler must select new process for the CPU frequently. So short term scheduler என்ன பண்ணணும், a new process வந்து has to be select CPU ல இருந்து frequent they has to be selected, but the long term scheduler other hand executes much less frequently. இது வந்து என்ன பண்ணுவாங்க, less frequent தான் வந்து execute பண்ணுவாங்க. ஏன், short term ன்றது என்னது CPU, correct? long term ன்றது job. Okay, so அப்போ long term scheduler வந்து other hand execute less frequently, அவங்க execute பண்ண சான்ஸ் கிடையாது. Okay, they will be placed all the process in same. But short term scheduler என்ன பண்ணுவாங்க, selected என்ன process ரெடியாக இருக்கோ அதை மட்டும் select பண்ணி they will assign to CPU to execute, correct? So another short term scheduler must select a new process for the CPU frequently. Long term on the other hand executes much less frequently. Okay, often the short term scheduler executes at least once every 100 milliseconds. A long term scheduler they may be minutes before the creation of the new process in the system. Okay, so the executes at least once every or process complete ஆயிடுச்சுனா again இன்னொரு process ready stateல வந்துரும், வெயிட் பண்ணிட்டு execute ஆகும். But long term scheduler they may be minutes between the creation of the new process in the system. Okay, with it 100 milliseconds இது வந்து it will take the minutes. Okay, so next, the long term scheduler controls the degree of multiprogramming, the number of processes in the memory. Okay, these are the things will be asked. Difference, give any two difference between the short and the long term அப்படினு கேட்டாங்க, have to select and write the any 2 points. Okay, so if the degree of multiprogramming is stable, okay, constant, then the average rate of process creation must be equal to the average departure time of the process leaving the system. So thus long term scheduler may need to invoke only when a process leaves the system. So here in the 2 points they are talking about long term scheduler in the concept of multiprogramming. Okay, So long-term scheduler will be control multiple programming. Multi-programming in sense more number of processes will be running in the memory, will be called as multi-programming, right? So degree of multi-programming will be stable irunduchna, the average rate of process creation is there, no? Process create பண்றாங்க first must be equal to the average departure rate. Okay, departure na complete rate. So நம்ம எவ்வளவு process we are creating it, that should be equal to the average completion rate of the process. Okay, அது leave ஆகுல, I mean system வந்து leave ஆகுல, CPU system CPU வந்து when they are leaving out. Okay, thus long term scheduler need to be invoked only when the process leaves the system. Okay, therefore long term scheduler they will be invoked it only when a process will leaving the CPU. Okay, because of the longer interval between execution, one process ko another process will be having a longer interval, right? So long term scheduler can afford to take more time to select a process for the next execution. So one process complete பண்றதுக்கு will be taking more time. So in the meantime long term process scheduler can utilize the time for the selection of the new process. Okay, the long term scheduler must make a careful selection in process. Okay, process select பண்றது should be very careful. In general, most process can be described as either IO bound or the CPU bound. Okay, further I will be seeing what is IO bound and the CPU bound. Okay, an IO bound process spends more of its time doing the IO than it spends doing the computation. IO என்ன பண்ணுவாங்க? Yes, of course they will be taking a more time for their IO only. Okay, instead of CPU. But CPU what it will do? It also take more time to spend for its CPU. Okay, rather than the IO doing for the computation. So an IO, I mean a CPU bound process other hand generates IO request infrequently. Okay, they're saying infrequently, using more of its time doing computation than an IO bound process uses. Yes, as I said already, right? So IO bound process spends more time of doing IO. But CPU on the other hand generates IO request infrequently. That means they are doing only CPU bound now. Okay, when compared to the IO bound. The long-term scheduler should select a good process mix of IO bound and the CPU bound processors. Okay, so long-term scheduler what has to do? It has to select a process mixed of the IO bound and the CPU bound. If all processes are IO bound, the ready queue will almost always be empty. And the short term scheduler will have little to do. So எல்லா ப்ராசஸும் நம்ம வந்து IO boundலயே select பண்ணிட்டோம்னா நம்ம ready queue வந்து empty-ஆ தான் இருக்கும். Okay, so and short term scheduler வந்து don't have any work to do. So always we must select the mix of the IO bound on the CPU bound process. Okay, if all processes are CPU bound, the IO waiting queue will almost always be empty. Yes, so device will go unused and again system will be unbalanced. So நம்ம IO bound தனியா select பண்ணக்கூடாது, CPU bound தனியா select பண்ணக்கூடாது. Always be in the combination of the IO bound and the CPU bound process we need to select it. So on some system the long term scheduler may be absent or minimal. Okay, for example time sharing systems such as Unix often have no longer scheduler, long term scheduler, but simply put every new process in memory for a short term scheduler. So some operating system they don't have a time sharing system. Time sharing இப்போ நிறைய டைப்ஸ் எல்லாம் இப்போ நியூ ஆப்ரேட்டிங் சிஸ்டம்ல தான் வந்துச்சு. இப்போ ப்ரீவியஸ் ஜென்ரேஷன் ஆப்ரேட்டிங் சிஸ்டம்னா they don't have a many features like what we have having now, right? So அப்போ they don't have a long term schedulerன்றதுனால they will put everything in the short term schedulerலே வந்து பண்ணிடுவாங்க. Okay, the stability of the system depends either on the physical limitation, okay, or on the self adjusting nature of the human users. Okay, so stability of system எதை சொல்றாங்க? அந்த Unix like okay depends on the physical limitations such as the number of available terminal எத்தனை இருக்கு and also self adjusting nature of the human user. Okay, அவங்கள யூஸ் பண்ணி they are doing all the work in the Unix like operating system. Okay, like a time sharing system. So addition of medium time scheduling to the queue diagram is our next topic. As I told already in the beginning, three types irukku: long, short and the medium term scheduler. So see the first point here. Some operating systems such as time sharing system may introduce an additional intermediate level scheduling. Medium, long, short. Okay, நடுவுல இருக்கிறது தான் middle. So it is called as the intermediate level of the scheduler. This medium term scheduler removes process from the memory. Okay, memory lane they are removing process and thus reduces the degree of the multiprogramming. Okay, so many process will be dumped in our memories in order to avoid that. What a medium term scheduler they are doing, they are removing certain process from the memory, thus they are reducing the degree of multiprogramming and they are reducing it. Okay, so here it is, I'll explain that. So next, at some later time, the process can be reintroduced into the memory and executed and can be continued, and where it is left off, this scheme is called as the swapping. Okay, so remove பண்ணிட்டாங்க, again they are reintroducing that process. யாருக்கு memory-க்கு first we have removed from memory, no? So now they are reintroducing the same process to the memory, execute பண்றதுக்கு எங்க அவங்க left ஆனாங்களோ அதுல இருந்து begin பண்ணி execute பண்ண வைப்பாங்க. So அதான் swapping. This process swapped out and later it is swapped in by medium term scheduler. First swap out பண்ணாங்க, next swap in பண்ணாங்க. மெமரியில இருந்து ப்ராசஸ் எடுத்தது வந்து swap out, again மெமரியில வந்து ப்ராசஸ் பிளேஸ் பண்ணது வந்து swap in. So this concept is called as the medium term scheduler. Swapping may be necessary to improve the process mix or because a change in memory requirement has overcommitted available memory, require memory to be freed up. Okay, some memory over dump ஆகிரலாம free பண்றதுக்கும் we are using the swapping concept. Okay, let's see the diagram so that you can understand. So this is the ready queue. So job queue முன்னாடி இருக்கும், multiple process will be placed, அத pool of jobs will be placed in the job queue. அதுல இருந்து I have selected some one process. Okay, அது else it will be in the ready state or the waiting state ல வந்து ready queueல இருக்கும். Okay, so CPU என்ன பண்ணுவாங்க, process வந்து select பண்ணிப்பாங்க execute ஆகிறதுக்கு. So my process has goes here. Okay, so process happen ஆயிடுச்சு, complete பண்ணி வெளியில வந்துடலாம். இது வந்து first. Okay, இப்போ so process வந்து CPU க்கு வந்துருச்சு, correct? So but higher priority process has come. இங்க வந்து higher priority process இங்க வெயிட் பண்றாங்க. ஸோ அப்போ நம்ம lower priority கன்சிடர் பண்ணணுமா, higher priority கன்சிடர் பண்ணணுமா? We have to definitely consider about the higher priority. அப்போ higher priority has to come here, right? So lower priority process will swap out from the memory. Okay, partially executed swapped out process. அத கீழ சொன்னோம் இல்லையா, swap out பண்ணிட்டு again என்ன பண்ணுவாங்க, மெமரியில பிளேஸ் பண்றதுக்கு swap in பண்ணி again complete பண்ணுவாங்க. higher priority execute பண்ணி முடிச்சதுக்கு அப்புறம் low priority again it will come from here. இது வந்து second. இல்ல third என்னன்னா, so first அனுப்பின process இங்க execute ஆகுது, but அது வந்து ஏதோ IO காக வெயிட் பண்ணுது, IO device காக வெயிட் பண்ணுது. so அது என்ன பண்ணணும், again has to place in the IO waiting queue. This is called as the device queue. Okay, then IO கிடைச்சதுக்கு அப்புறம் from beginning ready queue ல இருந்து it will come here to the CPU and it will execute and complete the process. This is called as the medium term scheduling. Okay, can you understand? So last topic of today is the context switching. Okay, so switching the CPU to another process requires saving the state of the old process and loading the saved state of the new process. Okay, so other switching the CPU, ஒரு CPU ல இருந்து another CPU க்கு we are switching the processes. Correct. So it requires what, saving the state of old process. So switch பண்ணக்குள்ள we need to save the old process and also we need a time to load the saved state to the new process. Okay, so ரெண்டுத்துக்குமே வந்து we need some time. So this task is known as the context switching. Okay va? So ஒரு ப்ராசஸ்ல இருக்க first நம்ம old process வந்து சேவ் பண்ணிடணும், new processக்கு வந்து we have to upload it. Okay va? ரெண்டுத்துலயுமே வந்து we are swapping or switching the context, right? So this is called as the context switch. Again it will be asked in 2 mark. Okay, the context of a process is represented in the PCB, that is process control block of the process. It includes the நான் diagram முன்னாடி பார்த்தோம் இல்லையா, process control block, அதுல நான் have told it includes the values of CPU register, process data, memory management information. Can you remember these are the things we have seen in the process control block இல்லையா? CPU register பார்த்தோம், process ஓட state என்ன, waiting idea ல பார்த்தோம், memory management information ல store ஆகிருக்கணும். ஓகேவா? These all things consist. When a context switch occurs, the kernel, that is core part of our operating system, is called as the kernel, saves the context of the old process in its PCB and loads the saved context to the new process scheduled to run. First சொன்ன அதே கான்செப்ட் தான். ஓகேவா? கான்டெஸ்ட் ஸ்விட்ச் அக்கர் ஆயிடுச்சுன்னா கர்னல் என்ன பண்ணுவாங்க, they will save ஓல்டு ப்ராசஸோட contest வந்து will be saved in the PCB and load the saved contest to the new process. அங்க வந்து they will start to scheduled. Contest switch time is pure over it because the system does no useful work while switching. Okay, overhead na வந்து நம்மளுக்கு burden தான் இது. Okay, changing over it and again starting from the beginning. ஏன்னா இதுல வந்து no other use is there. Okay, its speed varies from machine to machine depending upon the memory speed, register, the capacity கேத்த மாதிரி, instructions கேத்த மாதிரி, machine to machine இதோட speed, I mean switching speed வந்து differ ஆகும். Typical speed range from 1 to 1000 microsecond. Contest switch times are highly dependent on hardware support. Okay, so இங்க எப்படி நம்ம வந்து memory speed அதெல்லாம் பார்த்தோமோ அதே மாதிரி contest switch பண்றதுக்கு நம்மளோட hardware resources support is also highly dependent. If it is highly dependent to us, it will even more speedily they will switching the contest. Okay, for instance, some process provides multiple sets of registers such as sun, ultra, spark சொல்றாங்க. இந்த மாதிரி processes நிறைய processes we have, right? But sun, ultra, spark processors are providing the multiple sets of registers. Okay, register another storing. Okay, that data store பண்றத will be calling as the registers. Okay, so today we have seen about process scheduling, right? Process scheduling பார்த்தோம், objectives ரெண்டு பார்த்தோம், uniprocessor multiprocessor பத்தி we have seen, scheduling queuesல job queue, then ready queue and followed by device queue and ready queue ஓட diagrammatic explanation. Okay, so followed by queuing diagram ஓட steps வந்து பார்த்தோம். So followed by scheduler, long term, short term and the medium term. Long in the sense job, short வந்து CPU, medium வந்து between ல இருக்கிறது வந்து medium or the middle term scheduler. So இதோட diagram later we have seen about some difference between short and the long term. Again long term பத்தி some points we have discussed and medium term ஓட 3 process. Okay, என்னென்ன process happen ஆகுது அப்படின்றது பார்த்தோம், swapping என்ற கான்செப்ட் பார்த்தோம், IOல வெயிட் பண்ணுன்றத வந்து we have seen and followed by contest switchingல வந்து ஒரு ப்ராசஸ்ல இருக்க கான்டெஸ்ட் ஓல்டு ப்ராசஸ்ல இருக்கிறத சேவ் பண்ணிட்டு சேவ் பண்ணதை வந்து நியூ ப்ராசஸ்க்கு வந்து லோட் பண்ணுவாங்க. that is called as the contest switching. அது ஸ்பீட்ல எப்படி வேரி ஆகுது, ஹார்ட்வேர் டிவைசஸ் வந்து எப்படி வந்து contest switchingல வந்து how far it is very important. Okay, like that we have seen. Okay, so in our next session we'll be seeing another topic. Okay, if you have any doubt here, kindly ask me and please complete the notes as soon as possible. Okay, take care.